This is a little video to help with memorizing the polyatomic ions. I'm going to begin by calling your attention to this little chart at the bottom of the periodic table that we use most often. Notice that most of them end in ATE or ITE, and ATE is more common than ITE. There are a couple of IDEs, and you just have to memorize those. I'm going to run through how to memorize names and then charge. I'll remind you what is in the other video that I posted on this page from Mr. Kent's chemistry page. All right, for memorizing names, notice they end in ATE or ITE. The ATE indicates what I would call the most common number of oxygens for that particular element. So, for example, you might have phosphate, that would indicate the most common or number of oxygens, or sulfate would be sulfur with the most common number of oxygens. Chlorate would be chlorine with the most common number of oxygens. The number of oxygens that's most common then is indicated with an ATE ending. If there's one less oxygen than the most common number, we end the name in ITE. So the names will either end in ATE, the most common, or ITE, one less. Now, there are a couple other prefixes too. I'll just mention those real quickly. We all know that hypo is a prefix that means less than. Like if you're hypoactive, you're underactive. So if we have hypo ITE, that would mean one less than whatever the ITE was. We also know that if you're overactive, you're hyperactive. So sometimes we have polyatomic ions that are in hyper, or one more than the normal. Now we don't usually use the HY, so if it's one more than normal, we take off the high and just call it per. All right, so I'll run through what that means in just a minute. So that'll be a per right there. Whoops. PER. All right. So now, on the periodic table, there's a little imaginary 4 that some of you may remember me talking about before. See that little 4 right there. So for elements that are in that 4, the ATE means O4. So if they're in this little imaginary 4, ATE means O4. So phosphate, PO4. Arsenate, ASO4. Tellurate, TeO4. For elements that are not in the 4, or those elements that surround the 4, if they're over here anywhere on this side of the table, around that 4, ATE means O3. So if you look at borate, BO3, right here. Or silicate, SiO3. Silicon's right here, so it's SiO3. So the ATE ending will usually mean O4 or O3. If the element's in the 4, you know the ATE is going to be O4. And if it's in the 3, you know that the ATE will be O3. Now when you get over here, you just have to memorize them. Like there's a chromate, CrO4, permanganate, MnO4. So you just have to memorize these. But for the majority of the polyatomic ions, the name can be determined by looking at its position relative to this imaginary 4. All right, what if you had something like this? So what's that called? That would be called what? All right, sulfate. Then if you put a hydrogen in front, now it's called hydrogen sulfate. So that would be down here. Right here, hydrogen sulfate, yep. All right, so now we're going to look at the PERs for a second. So if I have, what's ClO3 called? Chlorate. So what would ClO4 be? That's one more than the normal ATE. So that'd be called perchlorate. And you can see it down here. It's on this list, I think. Here it is, perchlorate, ClO4. Same concept applies to bromate and iodate. So if bromate is BrO3, then perbromate would be BrO4. And if iodate is IO3, then periodate would be IO4, and so on. Similarly, if you have an ITE ending, like iodite would be IO what? Iodate's IO3, so iodite's one less would be IO2. If you have just plain IO, then that would be hypoiodite. Okay, so that's a little background on naming. Now let's talk about charges for the polyatomic ions. For these over on this side, oops, lost my connection to the computer here. On the right side, I'll just talk about this since I'm heavily in the movie. This column will have a -1 charge. This column will be a -2 charge. This column, -3 charge, except for nitrate and nitrite, which you have to remember are -1. So the charges go 1, -1, -2, -3. Then it starts at -2 again, then -3. So it goes 1, 2, 3, 2, 3. So that's one way to memorize the charges. 1, 2, 3, 2, 3. Pardon me just a moment. All right, now I'm writing again. Okay, so now what? 1, 2, 3, 2, 3, except for nitrate, which you have to remember, nitrate and nitrite. Oops. Are both -1. So that's -1. All right, now another way to think about charges is by looking at the groups from which the elements originate. So the groups are numbered here, they're Arabic numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. If the sum of the group totals is an odd number, so let's take a look at, say, carbonate, CO3. See, carbon comes from group 14. Oxygen comes from group 16. If you add the two groups together, 14 and 16, that gives you 30. If the sum of the group numbers is an even number, the charge is going to be -2. And this works for anything that's 1 or 2. This one I'm about to show you. Now if you have, suppose you have permanganate, which is a name you're going to have to remember. But if you look at manganese, it's in group 7. And oxygen is in group 16. 16 and 7, so here, let's write it down, 7, 16. So 16 and 7 is 23. If the group sums are odd, you're going to have, oops, if the group, this was group 16. So if the groups are odd when you add them together, 7 plus 16 is 23, the charge would be -1. So most of the polyatomic ions are 1 or 2 for a charge, and you can tell by adding up the columns that they're in, the sum of the two columns. If the sum of the columns is odd, the charge is -1. Here's another one, OH. So here's a column 16, column 1, that's an odd number, charge -1. If the sum of the columns is even, the charge is -2. Like looking at sulfate, that's both of them are in 16. 16 plus 16 is 32. That's an even number, so that's a -2 charge. All right, one last comment. If you, the 3's don't work, but you can tell the 3's by the -3's come from our phosphate and arsenate, and you can determine their charge by the 1, 2, 3, 2, 3 rule, except for nitrate, which is -1, of course. All right, now sulfate's -2. You could figure that out by the charges. If you put an H with it, that's a 1. So -2, and then a +1 makes an overall charge of -1. So the overall charge for this compound, or this ion, would be -1. Let's check the groups. So this is 1, group 1, group 16, group 16. Notice how we got an odd number when we add them together, 16, 16, and 1. It's going to be a -1 charge. That works pretty well, except for maybe something like this. What if you have this compound, or this, not compound, polyatomic ion, H2PO4. So you know PO4 is minus 3 by our 1, 2, 3 rule. Minus 3, add a plus 1 and a plus 1, makes a minus 1. So that would be the charge on that particular polyatomic ion. So if you put hydrogens in front, you just add pluses to whatever the negative charge was. See, phosphate was negative 3, and 2 more plus 1s. Negative 3 plus 1 is negative 1. And the odd rule works too. So this is a 1, and this is a 15. And that's a 16. Oh, wait a minute. No, the odd rule doesn't work because an even number should be a minus 1. So you can't. You'll have to go with the rule about if this is negative 3, you got to add the 2 1s for that, because the columns don't work on that one since it has a negative 3 ion in it. All right. So it's a little bit of an overview of how to name polyatomic ions. Maybe that will be helpful. Bottom line is, if I can say phosphate and you know immediately it's PO4 with a minus 3 charge, it'll make life a lot easier in AP chemistry. That's it for this video.